Today we'll be investigating how the length of wire affects the current passing through the wire. Here we have a power pack. Now it's important we set our power pack to direct current so that the current only flows in one direction. The mains use alternating current, which constantly changes direction. Now we have our power pack connected to an ammeter, and our ammeter connected to our wire, and then our wire connected back to our power pack to complete the circuit. We will be using 6 volts to complete this experiment, so we will have a constant voltage. The only thing that will be changing is the length of the wire as our independent variable. Our dependent variable is current, which we will measure on our ammeter. So, the setup is actually made quite simple because the ruler already has a wire attached to it so that we can easily measure the distance between 2 points. I have my first crocodile clip at 10 centimeters and my second at 20. So this makes the length of wire to be 10 centimeters. I've made a chart to record my results with length of wire and current. We'll be using lengths of wire of a range from 10 centimeters to 60 centimeters. Beginning with 10 centimeters, I will turn on my power pack, and the current going through appears to be about 6.8 amps. It will vary, but I'll leave it at 6.8 amps for now. Now it's important that we turn our power packs off in between readings. Now that's because the wire will get very hot, as you can see here. And if the wire is too hot, it can make some of our readings inaccurate. So I will turn off the power pack and wait for the wire to cool down before taking my next measurement. I'll now place the crocodile clips 20 centimeters apart. As the power pack is off, the amperage is 0. When I turn it on, it will measure the amps and take a moment to stabilize. So we can see the current is 4.35 amps. 4.35 amps. Once again, I will write that on my results. And now on my results for 10 and 20 centimeters, and I'll once again do that for 30. So I will put my crocodile clips 30 centimeters apart, turn on my power pack, and the amp meter will tell me the current. It does take a few seconds to stabilize, but I can see the current is at 3.28. It will change back and forth slightly, but it is approximately that. So once again, I have recorded my results and turned off the power pack to allow the wire to cool before I take my next reading. You need to be very careful when conducting this experiment as the wire can become very hot and cause burns, so it's important that in between readings you turn off your power pack to allow the wire to cool and do not touch the wire with your fingers at any time. I now have my crocodile clips 40 centimeters apart. I will turn on my power pack and the reading I get is 2.65 amps. Once again, I will turn it off. I have recorded my results in my chart, and I'll put the wires now 50 centimeters apart. See, the current has decreased to 2.20 amps, which I have recorded in my results. Once again, I will turn off the power pack, move the wires so that the crocodile clips are 60 centimeters apart. We'll turn on my power pack, and I now have my final reading of 1.89. Now that I have completed my results, I will graph them. Here we have a graph. We can see that as the length of wire increased, the current decreased. To To describe a graph, we always start with the x-axis, and the x-axis always increases. So we always say as x increases, or in this case, as the length of wire increases. So as the length of wire increases, we can see that the current is decreasing. So we describe this graph as x increases, y decreases. Now to put it in the words, we'd say as length of wire increases, current decreases. As we increase the length of wire, the electrons, which is the current, the flow of electrons, encounter more what's called resistance. And the more resistance they encounter, the longer time it takes the electrons to complete the circuit. So since the length of wire is increasing, the time's increasing, meaning the resistance increasing. This decreases the current. In summary, when we increase the length of wire, we increase the resistance of the wire, which decreases the current. One way to think about resistance is like a traffic jam. Resistance is all of the electrons trying to get through this wire at the same time. The more electrons there are, the more difficult time they'll have getting through, so the more resistance they will have.